All right, so another measure of position are what are called percentiles. Percentiles are a little bit like quartiles, only instead of breaking the data up into 25%, percentiles, the idea behind it is to break the data up into 10 equal parts, percentages, right? So kind of like your test scores. 10, 20, 30, 40, 50, 60, 70, 80, 90. There's usually are the breakoffs for your A's, B's, C's, and D's, right? Even though some schools mess around with the grading scales, whatever, right? So we divide a data set into 10 equal parts, and then we take one data piece and kind of take a look at where it is in the data set in those 10 equal parts and talk about how many data pieces are below that, how many are above that, and things like that. Only instead of doing it in 25%, like I said, we do it in 10%, which is kind of odd because we are going to use the ones digit to talk about a percentile as well. But again, we're trying to compare some data points. You'll hear percentiles a lot in the education field. Your test scores, NWEA scores, your reading scores sometimes, SAT scores are given to you in reports of percentiles. And then the medical field uses it a lot as well. When you guys get older and start having kids, you'll hear that a lot talked about in terms of your kids' growth charts, right? So, for example, this is an idea of what a growth chart would look like for babies, right? So this is for baby boys from birth to 36 months. So this is kind of how your child should be growing, how your son should be growing from the time they're born until 36 months, right? And so you have to look along the x-axis down here to see that that is the age in months. And then the y-axis is weights in kilograms, right? And then there's curves. There's different curves. And those curves correspond to the percentiles, right? 96th, 90th, 75th, 50th, 25th, 10th, and 5th. Okay? So, some questions. 9-month-old weighs 21 pounds. How does he compare to other 9-month-olds, right? Is that normal? Well, 9 pounds puts you about right where that orange dot is, which places them just above the 50th percentile curve. So what that tells you is that this particular baby boy, weighs more than about 50% of other 9-month-olds, boys, 9-month-old boys. Yeah, you got to be specific that way. Okay, so this 9-month-old boy weighs more than about 50% of the other 9-month-old boys. So what? Probably about average, right? Is kind of how you would think about that. All right. A 24-month-old weighs 32 pounds. Okay. Let's back up, right? So in the 50th percentile, right? So think about that. 50th percentile kind of puts them at the median, right? So half baby boys weigh less than this kid, half baby boys weigh more, right? So a 24-month-old weighs 32 pounds. How does he compare to other? Well, we don't want to compare him to 9-month-olds. We'd want to compare him to 24-month-olds, right? So if a 24-month-old weighs 32 pounds, we want to go to 24 months, which is down here, and go to 32 pounds, which would place you at that orange dot right there, okay? And so again, we're comparing, you don't ever want to compare a 24-month-old to a 9-month-old. It doesn't make any sense, right? Well, that particular kid sits on the 90th percentile curve, right? So that particular kid is in the 90th percentile. So this boy weighs more than 90% of other 24-month-old boys. Okay, so 10% of 24-month-old boys weigh more than this kid, right? So is this particular boy pretty heavy, right? Definitely heavier than 90% of other 24-month-olds. I'll leave it for a medical professional to tell you if it's too much or not. But anyway, it just gives you an idea of where your son might compare to other 24-month-olds. Okay? 90th percentile would definitely put them in the top 25%. So if you think about it in quartiles, it would put them in between Q3 and the max, right? So just again, trying to relate it back to what we've done in the past. Next question, if Billy is 30 months old and is at the 10th percentile, what does he weigh, right? If he's 30 months old and is at the 10th percentile, that would put him at this orange dot right here, right? And at that orange dot right there, he weighs about 26 pounds. Okay, 10th percentile means that 10% of boys 30 months old weigh less than Billy, 90% weigh more, right? So maybe on the small side. He's in the bottom 25%, right? And for certain things, you want to be in the bottom 25%. You want to be in the bottom 10%. Some things you want to be in the top 10%, right? Where's your GPA? Your class rank is the same way, right? Your class rank would let you know. It's usually reported as a percentile, let you know what percentage of kids have a GPA higher and what percentage have lower. Okay? Now, we've talked about percentiles before when we were talking about ogives. Ogives, cumulative relative frequency graphs, are percentages that are created with the entire data set in mind. So remember that cumulative frequency is that we're always adding the number of data pieces in the next interval. So it's a running total, and we're getting an idea of what percent of data pieces are less than a particular value, right? So here we're talking about a particular score on a test, right? And let's say that you got a 42 on the test, right? Whatever that is. That puts you at that blue dot. Well, if you got your test back and you had a 42 on it, I don't know if it's percentages or not, but that would mean that you're at the 10th percentile, right? 42 is, you see it there, here, and you move over to 10th. It means you're in the 10th percentile, which means 10% of the kids scored less than you, 90% of the kids scored higher than you. So maybe you didn't do so well on the test, right? Versus if you scored, what did this dot corresponds to like a 62. That would put you in the 90th percentile, right? So to score higher than 90% of the kids, you needed to score a 62, right? So again, it's always it's just a way of comparing a data piece to the other data pieces in a set, kind of like quartiles. They're just broken down into smaller pieces of 10% instead of 25%. Okay, and there you go.